Moving on to triple angle identities, let's take a quick recap on what we have learned so far on the first fundamental identities and also the double angle identities, including the sum and difference identities. So for the fundamental identities, we learned that cos squared theta plus sine squared theta is equals to 1. Likewise, if we divide all through by cos, we will have that 1 plus tan squared theta is equals to sec squared theta divided all through by sine. We will have that cot squared theta plus 1 is equals to cosec squared theta. These are the fundamentals. Now to the sum and difference, where we have sine A plus or minus B will be equals to sine A plus cos B plus or minus cos A sine B. Moving on to cos A plus or minus B, we have this to give us cos A cos B negative positive sine A sine B. And finally, we have that tan A plus or minus B is equals to tan A plus or minus tan B divided by 1 minus plus of tan A multiplied by tan B. This is for the sum and difference. Now moving on to the double angle formula, we have the expression that sine 2A is equals to 2 sine A cos A. Cos 2A has 3 expression: cos square A minus sine square A, which is the same thing as 2 cos square A minus 1, which is also the same thing as 1 minus 2 sine square A. And finally, tan 2A is equals to 2 tan A divided by 1 minus tan square A. This is for the double angle formula. Now let's move on to triple identities. In triple identities, we have explained having sine 3A cos 3A as well as tan 3A. Now, how do we have such identities? How do we simplify them? So it's simple. All we just have to do is to implement that sine 3A is equals to sine 2A plus A, and we'll just apply the trigonometric identities of sum A plus or minus B. So with this, we remember that sine A plus B is equals to sine A cos B plus cos A sine B. Therefore, we have that sine 2A plus A will be equals to, so wherever we see A, we substitute 2A, and wherever we see B, we substitute A. So we are saying that sine 2A plus A is equals to sine 2A cos A plus cos 2A sine B, sine A rather. So now we want to put everything in terms of sine. So let's make sine substitution of sine 2A. We recall in our double angle formula that sine 2A is equals to 2 sine A cos A. So we have 2 sine A cos A for sine 2A multiplied by cos A. Similarly, we are going to represent cos 2A in terms of sine, and in terms of sine we have that cos 2A is 1 minus 2 sine square A, and we are multiplying this by sine A. So let's open up the brackets. Opening up the brackets, we have this to give us 2 sine A cos square A, because this will give us cos square A, plus sine A minus 2 sine raised to the power of 3A. So interesting. Then we'll move on. Moving on now, we want to make cos square A so it's a formula. And we understand from the first trigonometric identity we got that cos square theta plus sin square theta is equals to 1. So with respect to that, we can write that sin square A plus cos square A is equals to 1. So let's make cos square A subject to formula. So making cos square A subject to formula, we have this to give us 1 minus sin square A. So we now substitute 1 minus sin square A to this for cos square A. And with respect to that, we'll have 2 sin A into 1 minus sin square A plus sin A, okay, minus 2 sin raised to the power of 3A. So proceeding on that, we have multiply the bracket, so we have 2 sin A minus 2 sin raised to the power of 3A, 2 sin A, that's sin, and 2 sin A multiplied by minus sin square A plus sin A minus 2 sin raised to the power of 3A. With this, we have that 2 minus 2 sin cube A will nullify, okay, it won't nullify, but then 2 sin A will sum up with sin A to give us 3 sin A, and minus 2 sin 3A and minus 2 sin cube A will sum up and we'll have minus 4 sin 3A, and this will be our expression for sin 2A plus A, which is equals to sin 3A. So with this, we have evaluated for sin 3A that sin 3A is equals to 3 sin A minus 4 sin raised to the power of 3A. Proceeding on, let's evaluate for cos 3A. Cos 3A. Cos 3A will be written as cos 2A plus A. So therefore, we are going to have the expression of cos A plus B. Cos A plus B is written as cos A cos B minus sin A sin B. Therefore, we have cos 2A plus A. That means wherever we see A, we substitute 2A, and wherever we see B, we substitute A. So this will be cos 2A cos A minus sin A, or sin 2A rather, sin A. So in view of that, we multiply out and we make our substitution. Now in sin, we notice that sin 3A, all the components are in sine function. So for cosine function of 3A, all our components of cos will be in the cosine function. So let's have our expression of cos 2A now, which is 2 cos A minus 1. So we have 2 cos A, or 2 cos square A minus 1 multiplied by cos A, and we have sin 2A, which we remember as sin 2 sin A cos A multiplied by sin A. So we open up the brackets, we will have 2 cos cube A minus 2 cos A minus 2 sin square A cos A. Similarly, we recall in our expression of sin square A plus cos square A to be equals to 1. Then we have another expression of sin square A, which will be equals to 1 minus cos square A. So with this, we can now simplify, making a substitution of sin square A. So with this, we'll have that sin square A is equals to 1 minus cos square A. 1 minus cos square A multiplied by cos A. And we'll have 2 cos cube A minus 2 cos A. So moving on, we'll have 2 cos raised to the power of 3A minus 2 cos A minus 2, simplifying the bracket, cos A plus 2 cos raised to the power of 3A. And with this, we have an expression for cos 3a, because when we sum up these two together, 2 cos cube a plus 2 cos cube a, we have 4 cos cube a. And when we sum up minus 2 cos a with minus 2 cos a, we will have minus 4 cos a. Okay, there is an error here. When we multiply minus 1 with cos a, the result should just be cos a, not 2 cos a. So this will give us cos a, likewise this and this. So when we sum up minus cos a with minus 2 cos a, we'll have minus 3 cos a. Apologies about that. So we have an expression for cos 3a, which is this, that cos 3a is equals to 4 cos cube a minus 3 cos a, which is what we have here. Now let's find for tan 3a. Tan 3a, as you have guessed right, will be an expression of tan 2a plus a. If you recall vividly about what tan a plus b is, tan a plus b is equals to tan a plus tan b divided by 1 minus tan a tan b. Therefore, we are saying that when we are having tan 2a plus a, wherever we see a, we substitute 2a, and wherever we see b, we substitute a. Moving on, we'll have that this will give us tan 2a plus tan a divided by 1 minus tan 2a multiplied by tan a. Now this might get a little bit interesting, because the expression of tan a excuse me, the expression of tan 2a involves a bracket, involves a fraction. So we have that tan 2a is equals to 2 tan a divided by 1 minus tan squared a. So let's implement that here. Tan 2a is equals to 2 tan a divided by 1 minus tan squared a. So we have it plus tan a. We are still in the numerator. Moving on to the denominator, we have this to give us 1 minus tan 2a, which is 2 tan a. Let's rewrite that. This is the beauty of trigonometric identities. So tan 2a is 2 tan a divided by 1 minus tan square a. Multiplied it by multiplying this by tan a. So now all we just have to do now is to simplify this function. Just bring the equals to downwards. Yeah, I'll just have to simplify this function. And simplifying this function, we will look for the LCM of the numerator and the denominator. So let's begin with the numerator. The LCM of the numerator is going to be 1 minus tan square a. And when we simplify it further, we will have 2 tan a plus tan a multiplied by 1 minus tan squared a. Similarly, when we move on to the denominator, we will find out that the LCM in this case is also 1 minus tan squared a. And when we simplify further, we will have this to give us 1 minus tan squared a, because we are multiplying it by 1, minus 2 tan a tan a. So since we have the same denominator on both the fraction of the numerator and denominator, we will have this to equate 2 tan a plus tan a into 1 minus tan squared a divided by the numerator of the denominator. So we'll have it divided by 1 minus tan squared a minus 2 tan squared A, because we have simplified this. Or let's also say 2 tan A tan A. Now we are still on simplification of tan 3A. So now let's open up the bracket. So open up the bracket, we'll have 2 tan A plus tan A minus tan raised to the power of 3A divided by 1 minus tan squared A minus 2 tan squared A. So with this we have an expression of tan 3A. That's tan 3A is equals to 3, because tan A plus tan A will give us 2 tan A plus tan A will give us 3 tan A minus tan 3A divided by 1 minus tan square A minus 2 tan square A will give us minus 3 tan square A. So now we have an expression for tan 3A to give us 3 tan A minus tan cube A divided by 1 minus 3 tan squared A. So now we have established the fact of sine 3A, cos 3A, and also tan 3A. Let us take a quick example. I understand that the video is very long, but let's take a quick example. Question 1, just a 1. So we want to evaluate for tan or sine 90 degrees using the triple angle formula or triple angle identities. And in this case, we understand that sine 90 degrees should be equals to sine 3 multiplied by 30 degrees. So therefore we will be using sine 3A, where A is equals to 30 degrees. So with that, we recall the formula for sine 3A. The formula for sine 3A, just as we have established, is 3 sine A minus 4 sine cube A. So let's write it down, that sine 3A is equals to 3 sine A minus 4 sine cube A. So with this, we make the substitution of 3 30 degrees, which is equals to sine 90 degrees. So be equals to 3 sine 30 degrees minus 4 into sine 30 degrees, all raised to the power of 3. Sine 30 degrees raised to the power of 3. Now from our special angles table, we know that sine 30 degrees is equals to 1 over 2, and we'll have 4 into 1 over 2 raised to the power of 3. So simplifying, we'll have 3 over 2 minus 4 multiplied by 1 over 8. Simplifying further, we have 3 over 2 minus 1 over 2. So with respect to this, we'll have 3 over 2 minus 1 over 2, and this will give us, the LCM is 2, 3 minus 1, which is 2 over 2, which is equals to 1. So therefore we have sine 90 degrees to be equals to sine 3 of 30 degrees, which is equals to 1. And if we take a look at our special angles table, we will have that sine 30 degrees, which is equals to 1 over 2, and we also have sine 90 degrees, which is equals to 1. You can as well do the same thing for cos 30 degrees to evaluate tan, or to evaluate sine cos 90 degrees. Do the same for cos 30 degrees to evaluate cos 90 degrees using the triple angle identity.